Good day to you. This is our third part in the series where we're dealing with the proton and attempting to get to the electron and eventually the photon. That is what we really need to understand because of its enormous impact on how we understand light. That really is what the photon is said to be. So we have found some interesting relationships between the proton and the electron that go way beyond plus minus charge, which is very useful in our harnessing of electricity, which is why we concentrate on that aspect. However, it's much more important to understand the geometry, and the proton obviously has distinguished itself as a static, spatial contractor, manifesting what we call centripetal force, because that is a spherical force going in towards the center, which raises a paradox we're going to address right now. We also want to address the in this case it's not the anti-paradox, but the paired paradox. Because going in towards the center implies, obviously, there's some limit going in, and there is. And that would be called the infinitesimal. That's the mathematical term for it, which implies there's such a thing as the integral. But here's where we need to shift gears because of what happens in the contracting of space as we can perceive it from the behavior of the electron. The electron reveals something about the effect of the protonic force, which conversely illuminates what the electron is doing as well. So these two particles must be viewed together geometrically. That is, they're doing what they're doing because they are antithetical to each other in the most fundamental sense, yet penetrated by the mind of man. And so that's where you and I are going right now, is to go further than anyone has ever seen in the construction of reality. So what we call physically real is found in the relationship between these two particles, and the fundamental nature of what's going on is so fundamental that it has got to blow our minds. But let's at least say what it is so we can decide if it's mind-blowing or not. The proton pulls space in, and it's the only thing in the universe that does that. And to say that so does a star or a planet doesn't change a thing, because it's the protons in the star or the planet that are making it produce gravity. It's exactly the same force, and it is a force because it has the power of bending space. I don't think there's any definition of force that could overlook the fact that if you can bend something when it's not ordinarily bent, then it must be a force. It's not a pseudo-force as is stated in so many textbooks. But there is a reason why it's been called a pseudo-force, and it's very important to see why. It's because of electronic force. It's not electrical force, but it's the nature of the electron that it produces electrical force, which is motion. It's the motion that produces electricity. Magnetism is not motion. It's the bending of space again. So this is exactly the same thing. Electricity and magnetism are exactly the same thing as the electron and the proton. Well, that's interesting, isn't it? Because the proton cannot produce anything that goes out. That's not what it does. And so it has nothing to do with light. Nothing whatsoever to do with light. Which, let's just remind ourselves, what is light? It's the only thing in the universe that goes out. And so it is an atomic force. But then you have to narrow it down. It's an atomic force. Well, that doesn't seem likely. if you look at it from the point of view of the proton, because the proton has nothing to do with light, but the electron does. It's the electron that produces the photon. And here I need to make a very difficult distinction. At least it will sound difficult because it's been difficult for the physicists. First of all, if you consider the photon as a particle, which you might, let's just, because that is the way the particle physicists say it. They say that the photon is a particle. And it is thought that Einstein proved that. Well, it was thought that Max Planck discovered the quantum, but we're just about to disprove that. And the considered fact, that Einstein proved the particle nature. Now, you could say the particle nature of the photon. That is, you could say that light has a particle-like nature. That is not going too far, but it's definitely not a particle. And we're getting to why we can say that absolutely. But the more, I would say, for our purposes, the more interesting aspect is the electron a particle? Now, we've already determined that if it is considered to be a particle, it can only be considered a particle without reference to the proton at all, except at scale, that the electron is at the same size scale. But if they could be seen side by side, the proton would look solid more than the electron, for the simple reason that the electron is exactly the opposite of solid. It's a wave. As far as we can tell, the proton is not wave-like. It's actually as particle-like as anything can get, because it's the only thing that can be called a particle-like particle. But if the electron can be called a particle at all, it's only due to an illusion. It is not even spatial. It's not a spatial thing. It's a wave thing, and a wave thing cannot hold itself together in space. We know that because of the behavior of the photon. And that really is the difference, is that an electron can hold itself together as a wave, but a photon cannot. A photon cannot hold itself together as a wave. It is an expanding spherical surface. It's very interesting that spherical propagation of light can be somewhat overcome in the use of laser technology. And I think you know about lasers, most people do. They're actually, even some of the cheap ones can be quite dangerous, and you have to know what you're doing because it's never safe to shine one in your eye of any strength. It's only a question of how quickly it burns out your retina. But for every split second that laser is going into the back of your eye to hit the retina, your retina is in serious trouble right there. There are some lasers that normally you would not be able, you would have to know what you're doing. You would have to want one. You're not just going to find one lying around. But if you had one of those lasers and you somehow shone it into your eye, you'd lose your vision in that eye very quickly. So lasers are nothing to mess with. But that shows the high energy state. And it's the high energy state of the laser that contributes to its coherence. But ordinary light, which I would say is pretty ordinary if it's coming from a star, most of the light in the universe is from stars, although you do have to mention there is one other object that gives off light, and that is the quasar. And we've covered that in previous lectures. But light is really, that's where we learn a lot about the electron, because it's the electron that produces the photonic. And it would be better to call it that, because every time certainly when I say photon, I think of a particle, because that's what I was taught to think of it as. Unteach yourself that. The photon is definitely not a particle. But you have to be able to say that so that it can be proved somehow. Well, just the fact that it propagates as a wave is enough. So it's not a particle for that reason. And that's been known since the time of Christian Huygens. Now, Newton knew about that. He was contemporary with Huygens, but he thought of the particle of light as, he called it a corpuscle, which is, it's a unit. And it is particle-like. It definitely is in the photoelectric effect, which Einstein studied and got the mathematics for it. Got a Nobel Prize for it, too, when he did not get one for relativity, but he did get one for discovering the particle-like nature of light. But it's not a particle at all, and we're coming to that so that we'll actually know that, finally, so that we're done with that. Although the same experiments can be done to show its particle-like nature. That won't change, but we have to discover why it looks like a particle when it absolutely is not a particle. And from that we'll have the same form of reasoning which will allow us to realize that Max Planck did not discover the quantum. What he discovered was the quantum-like nature of energy. And that word "like" is very important because that's not really true. It's a deception, partly of our physiological nature, but actually that handicap can be overcome when you see things in the right geometry. And that's what I'm going to show you. Because what's actually happening in the determination of the particle nature of light and the particle nature of energy, which is the quantum, both of which are quanta, they're both quantized energy. So in that sense, there's no questioning that they're particles. If you think of a packet of energy as being a quantum, yes. But what makes it a quantum? It's spatial separation only. When you look at we can't look at a photon, but we can kind of look at an electron, and it is definitely not a particle. Because we already know what a particle is. It's a proton. And the electron is eerily the opposite. Eerily the opposite. And I'm going to show you why. It's because of something imaginary. And this, if you would, this is getting a little ahead of the game, but this is advanced stuff, and I want to give you some stuff. I already know this, but I'm going to explain to you what I know. But I'm giving you something ahead of time, is that when space contracts and its center is either at the proton or in the proton, well, which is it? Where's the center? When we think of the center, such as the center of gravity, this would be what we would call a point. But I've proved, and you should accept if you don't know the proof that I've already discovered, which was discovered only in 2022, there is no such thing as a point. Because the nature of the point, even geometrically, even the way we know at all what a point might be, is only on a line. Only a line could have a point. Because of the definition of what a number must be on the line, it has to be a point on the line. That's where we got the notion of point. It's an indivisible position. In other words, it has no radius. It's pure position. And as such, that would be correct. In other words, it's not real. It's purely numeric. So there's no such thing as a physical point. There's no match. There's no such thing as a point in space. But there is such a thing as a point in our grid that we impose on space in our minds. It's an overlay in our minds that is not in the universe. And that, if you would, is part of the impetus behind Bernardo Kastrup's, not necessarily his philosophy as such, but the natural attraction to his philosophy. He's on to something that he knows is true, which is that we're not seeing reality correctly. And I'm going to show you why Bernardo is right. The reason why we are forced to say that a center is a point is because we don't begin with the geometry that would give us what a center would be. But I've shown, and I'll just sum it up for you, that if you begin your geometry by assigning a two-component number to the edge, infinity over 1, then you are forced by mathematical reciprocation to have an infinitesimal at the center, because you've unitized the integral. And since that's a direct contradiction, first of all, the number is imaginary. But second of all, you need two imaginary numbers to make that coherent, consistent. And my magnificent discovery in 2022, it's also closed. So spherical space, when it's constructed on the integral infinitesimal bipolarity, that the center is one pole and the edge is the other pole, then the center is an infinitesimal number that's not zero, it cannot be zero, to the proportion that the edge cannot be infinity. To the proportion that the edge cannot be all of infinity. So we do have to apply a bound to spherical space to consider it in geometry at all. And without geometry, we can't do anything with it, and we never have. But this is how to get at it, so we can get at it with physics. It is finite, and we know that because if it were physically infinite, it would be irrational. And so it is finite, but it's not spherically finite. And here's where it gets to imaginarity. There's a reason why we need imaginary space. And it is imaginary, but the definition of imaginary space here, it's contra-real. It's not imaginary like we're making it up. It's that it's just as real as space. And that space is time. Time is a space that's just as real as space-space. We have time-space and we have space-space. And that's just a really ridiculous tripping over words. We need a new word for one or both of these things. And it's really even hard to say what kind of a thing is space. Well, we know one thing about space that we didn't know before the time of Einstein. It can be bent. It can be curved. It can be pulled in by centripetal force. And the thrust of this argument is that the manifestation of the particle that we call the proton is the manifestation of space. The proton is space. The proton makes space. Does space make the proton? No. And therefore, there's something about the proton that requires an antiparticle. But we already are using the word antiparticle for things that are mathematical constructions, such as the antiproton, and it's even been said there's such a thing as an anti-electron. But both of these are not antiparticles. What they are mathematically conjugate particles, due to the limitations of physiology and mathematics. We're now going to transcend both of those boundaries by seeing the truth, which is geometrical. And then we can get the mathematics, and then we can discern reality. So the way to begin to perceive that is with a fundamental identity that the proton and space are exactly the same thing, except that the proton has a harmonic in it. And it's the harmonic that governs space with a specific force that has to have a contraforce. So this force is the force that pulls space in. What is it pulling it into? It's pulling it into contraspace. And in order to see what that possibly could mean, we need the Boshkovich force curve. But before we do that, I want to show you the contraforce. The electron manifests centripetal force. It's not pulling space in. Instead, what it's doing, it's pushing time out. And it can't because it's locked. It's very difficult to say, and I'm not sure anybody does know for sure what holds the electron together. Why doesn't it just turn into a photon and go out? We don't know, but I think I know. It's also a harmonic, and I discovered that it's the same 2-1 harmonic, but in antispace. That is, the proton is known to have a 2-1 harmonic. I should say it is known to manifest a 2-1 harmonic, and that's redundant. You could also just call it the simple harmonic. The simplest harmonic in the universe is the 1-2 relationship, because now it can oscillate. Where as this one goes to 1, this one would be going out to 2. And then as this one collapses, this one opens. So this is going to 1 to the same proportion that the other one is going to 2. This goes to 2 as that went to 1. Now this one starts to go back to 1 as this goes to 2. This is manifest on the circle, and it can be shown that it's manifest on the sphere. And I spent a long time researching this last year. And the conclusions I reached were so deep that I had to start making videos in order to organize my own thoughts, because it's ultimately spooky. But it's ultimately satisfying. The more I see of this, the more I realize this explains everything. And I've come huge strides further than when I first noticed this relationship. So what I'm trying to do is introduce you to the path that I got on, because it leads to every insight, all the answers. But it does require quite a few strange perceptions. For instance, it's a natural question, if you would just consider, what is space being pulled into? Oh, okay, space is curved. There's centripetal force manifest. Certainly the force of gravity is well known to us. Anywhere above the surface of the Earth, if you don't have sufficient perpendicular velocity to maintain an orbit, you'll start to go in and then you will plummet straight toward the center of gravity. And why? That is spooky action at a distance. Well, the answer is that the space is curved. Space is contracted. It's contracted. Well, at the center would be the maximum contraction by definition. Well, what then? No, that force has to be balanced by something pushing out. And the proton does not manifest that at all. So it's only manifesting half of reality. That everything we see in the universe is spinning in. That's a fact. Except for one thing, light. Only light goes out, and that's the function of the electron. And the electron is barely held in centrifugal force. The proton is barely manifested centripetal force. Because logically speaking, it should destroy itself. A force that pulls space in should not be able to exist, because what could do that and still be real? Well, a harmonic. A harmonic could do that. But what kind of a harmonic? That cannot be decided, and the microphysicists have not been able to decide that, but Gelman discovered it. So it is there to be interpreted. Well, you can't interpret it unless you know what the electron has. It also has the same harmonic, but it has the opposite valence in spherical space. Instead of pulling space in, it's pushing time out. The electron is a captured piece of time to the same proportion that the proton is a captured piece of space. And the way we can say that and have it make sense is that the proton is space. It's what makes space. There would not be any space if it weren't for protons. But it turns out that makes no sense. But what does make sense is that the proton could not have space to bend if there weren't space. So where does space come from? It has to be manifest by something. I just tried to say that it's the proton, but it's not. The reason that we know that the proton is bending space in the ultimate sense is that we know that there's space. But how do we know that there's space? We know that there's space because of light. We know of space because of light. Light. Would you be able to say that light travels through space? I would. All of science has said so. But do you know what you're saying? How does light travel through space? Do you know its speed? Of course you do. You could just say c and that's good enough. The speed of light is c. Well, that is a space-time relationship, right? Well, that's a fixed space-time relationship. So it's a geometric relationship. And moreover, that is division. And therefore, space over time is light speed. We say distance over time. There's only one interpretation of distance. It's space. It's the metric of space. But when you say distance, you're talking about space. When you're talking about time, you're not. When you're talking about time, you're talking about motion. And you're actually talking about energy. Now, in order for the proton to be exerting a force, we think of that in terms of energy. It's not. It's contra-energy. It's anti-energy. And it's an energy that doesn't behave the way energy does. It behaves the way energy would if it were energy in space alone without motion. And that's the exact definition of centripetal force. It's force without motion. Centrifugal force is motion without an impetus, without a reason. The photon goes out for no reason at all. Science has never described why light goes out. Whenever light is produced, that is what we would call photons, but whenever light is produced, which is always from electrons, so you can say when electrons shed energy, when electrons shed energy from whatever system binds electrons, in the case of an atom, we can see that the electron is bound to its gravitational sphere. And so it's behaving purely as a wave. It's no longer possible to pretend that the electron was ever a particle. The electron is never a particle. It's always a wave. But when it's an electron, it's in a standing wave. And when it's in the atom, it's a standing wave of much bigger radius. It has to make a bigger radius, but it's still bound. What binds it to the proton? Well, consider this. What happens when the electron that is bound to the proton, so it's just like a hydrogen atom, or any atom that's stable, when a photon comes in, it's absorbed by the electronic shell. That is a fact. So what happens next? There's an excess of energy in the shell system. And so what happens next is, this actually depends on certain things, but what will eventually happen is it will release a photon. What does that mean, that it releases a photon? Because it could just release it and make another shell. It doesn't do that. Or it could release it and it just floats around and wanders around. Doesn't do that. What does it do? It goes spherically out in all directions. This has been studied extraordinarily carefully to even be able to talk about it, because it actually doesn't make much sense. Because why in the world would it go out? And it could go out at like 2 feet a minute and just slowly go out. But it goes out at a very rapid pace, we would have to say from our perspective. It goes at the speed of light. Why is that considered to be ultimate? Do you know why? The speed of light is fixed for all time. Science has fixed it. That is said that it is exactly 300 million meters per second. Minus a tiny amount, but a fixed amount. So it's 299,792,458 meters per second exactly forever. It never will ever need to be changed. That's the only number we've ever said that about. So it's the only quantity in the universe that we're absolutely certain about is light speed. Why is it that number? There has to be a reason why that so-called particle expands as a spherical wavefront. And for the longest time, it was thought that that would mean that space must be a substance. Otherwise, there would be no way for the photon to resonate, because it needs a medium. No, apparently it doesn't, but I say yes, it does. It does need a medium, but it's imaginary. It's an imaginary space that we simply will never perceive at all. But we have to, and that's the ultimate paradox. We have to see that the universe is actually two overlapped realms. And they're always both there. And if you would, that answers the many worlds theorem. That the realm of time is coexistent with the realm of space. And here's the part that I discovered based on purely on the geometry of the situation that Einstein discovered, and that Ruger Joseph Bošković discovered at the quantum level, is that the relationship between these two spaces, the space of space and the space of time, are perpendicular. And that's 32 minutes. We'll be right back. This is Out of Galactic. I hope you're enjoying this. It's going to get more intense and more spooky. And if you can hang in there, then you're going to reach a watershed. And you could reach this at any time, but I predict it'll be in the next lecture or two. This will run through Christmas. And then suddenly, if you're awake and aware through this whole thing, and I will assist you in this, everything is going to fall into place like dominoes. And you'll see everything at once. And it will make perfect sense. I swear to God on that. So stay tuned. We'll be right back.